So now we're looking at a PNP bipolar junction transistor right there. It's off until I close the switch, and then it's on. The LED's on. So this is, which is not turning the LED on and off. It's turning the transistor on with a weak signal, or off because it cut off that signal. So now the PNP bipolar junction transistor will not conduct if there's no emitter to base current, because the switch is open, there's no current path. Whereas when you have a little bit of emitter to base current because the switch is closed right there, even though it's a high value resistor, just a tiny bit of current, the transistor will conduct really well, many times that amount of current, much more than 20 milliamps in this case, which is what the load is going to set. So it's just on completely right now. So now, when it comes to the bipolar junction transistor, schematic symbol, the side over here is the collector, base is over there, and then the emitter has the arrow. That's the difference between the collector. PNP, the arrow is pointing in, and PN, the arrow is pointing out. That's the difference. PNP bipolar junction transistors, though, have the emitter towards the positive supply. So you're more likely to see it drawn like this, where the emitter is above the collector, but it can be swiveled however is needed for the schematic diagram. So now, always check the data sheet for the pin layout, but if you're using the 2N3906 and the TO92 package, left pin is emitter, middle pin is base, and right pin's collector. Emitter to the positive supply, base or signal to ground, and then the collector is on the low side, as you can see there. So we got the emitter on top because we're facing to the left, base in the middle, and the collector on the load side right there. So now, the biggest takeaway when it comes to bipolar junction transistors, this is the PNP version right there. So whatever little bit of emitter to base current is flowing, that is needed to get many times the emitter to collector current right there. And these particular transistors have a gain of at least 100. You know, check the data sheet for the different ones you're using. But any case, we're pretty much guaranteed over 100 gain. So worst case scenario, for every 1 milliamp of current we get emitter to base, this will allow 100 milliamps of current to flow through there. Whatever you go above what the load needs, it doesn't matter. The load will limit the current to what it needs. Just the transistor needs to conduct well enough. So we got 5 volts minus 0.7 volts, leaving about 4.3 volts across the 10K resistor for about 0.43 milliamps of current. 100 times that would be 43 milliamps of current, and the load needs less than that. So the load will be what limits the current, not the transistor, when it is on. So now, on the diagram I made for the PNP bipolar junction transistor switch, I wrote high side right there. So what that refers to is the position of the transistor. And when it comes to the load, the transistor is either on the high side, the more positive side, which the PNP bipolar junction transistor is, or the transistor is on the low side, which is the case of the NPN, the opposite type of transistor right there. When this transistor is on, it connects the load to ground. So it's on the low side. Ground is lower than the positive side of the supply.